So just thanks for coming, and thanks for staying for the last hour and of the talk. So just as a quick intro, Joey, why don't you go first?
Yeah, I'm a product solutions architect at Hortonworks, and I'm a committer on the NiFi project and PMC on an Apache project called Streams.
And I work at Red Hat in the Office of Technology, focused on data science and machine learning, and I'm a member of Apache Foundation, and at PMC on Mahout, OpenNLP, and Streams again. So with those intros, let's move on to the talk. So the agenda for today is, we'll be talking about what is a schema registry, and why do you care about a schema registry, and why do you need it, and what is the landscape as far as the different schema registries that exist today, and what are the different wire formats that each of those registries support, and how do you use a schema registry in a Flink data pipeline, and how do you use that across a complete data pipeline. And we'll be looking at an example implementation using Flink deserialization. So before we go to the next slide, what is a schema registry? Are folks aware of this, and why do you need it? OK, so the reason what is a schema first? So basically, when you have streaming data coming in, you have data coming in, but you have no idea what is the data like, and what is the type of the data, and what are the different values that you have for the data. So and how do you do that? You have to define a schema for describing what your data is. And basically, a schema is basically the information you have about a record, and what are the different types of the fields you have in the data, and what are the default values, and any kind of aliases that you may have for these records. So a schema registry is kind of like a centralized version, and that also has version control, and wherein you upload your schemas, you define your schemas, and the schema registry is kind of a repository of your schema definitions. And it kind of supports like a decentralized, so you don't have to have the copy of the schema in your streams, and you can just read the schema from there, and you can deserialize and serialize your streams using the schema definition. And why do you care for a schema registry? Because number one, you need to know when you're doing streaming data, you have all the operations like aggregation, filtering, and projection and joins. And in order to do those operations, you need to know the semantics of your data. So if you don't know what your data looks like, and what the data fields are, and what is the format of the data, you cannot do that. Otherwise, you're just counting, doing a simple work, counting your data, and counting anonymous things. And for that, you don't need a streaming engine like Flink or Kafka Streams to do that. You can just do it on the plain data. And so given that reason, so obviously the next question is, OK, so what? Why do I need a schema registry? I can just include the schema itself, embed the schema into my messages, into the data that's going through the streams. Right, the downside to that is, it could so happen that your schema is so huge, like if I'm transporting a PMML file, the PMML file is much bigger than what actually the data is. And it could be much bigger than the data itself. And you got to copy that. You'll be duplicating the information across all the messages that are going through the streams, across all the data points flowing through the streams. And it's definitely not a good idea to include schema in your data itself. And number one, it's not scalable. And you're kind of tightly coupling your data itself to what the schema should be looking like. So that's the reason why we need to have a centralized schema repository, and you need to decouple yourself from what the schema looks like. So the general overview of what a schema registry offers. And so number one, it's kind of like a database repository of all your schema definitions, which you can upload to a central repository. And it enforces version control, so you can go back to an older version of the schema, or you can go back to the latest version of the schema. And you can also upload your binary jars. If you have a jar implementation, you can upload that, and you can obviously pull that down, binary artifacts. And schema registry also provides a REST API for schema management. You can manage your schemas using the REST API. And you can encode the schema using some kind of a wire format. You can just include the header, a schema header with a schema ID. When you upload a schema, you get a schema ID. You can encode that as part of your stream packets. It's much smaller compared to embedding the entire schema. And we'll be looking at an example of that in the forthcoming slides. So given this background about schema registries, what is the landscape like today? And who are the providers? There's no standard for this. So who are the guys who are providing schema registries? So We only have 3 options as of today. The first one is Cask. Cask, for folks aware of Cask, what Cask is? It's one of the, what do they do, Cask? It's a data, it's kind of like what NiFi does, but they have their own version of, it's called Data Cask CDAP Wrangler. So they have their own schema registry, and they support Avro as well as protobuf formats for the schemas. It's completely internal to the Cask, but nevertheless, they have one. Just for the record, they have one schema registry, even though it's not used outside of Cask. The other one is Confluent, what Confluent provides. And Confluent supports Avro schema formats, and it's pretty much what Confluent uses with the Kafka streams for serialization and deserialization. The third one is Hortonworks registry, which Hortonworks has come up with. And it supports, again, Avro schema formats. And it's kind of like, it's more involved in that. It's kind of like a shared repository. You can share it across different applications. Like it's used in Apache NiFi, as well as it's used in Hortonworks Stream Analytics Manager, which is for Storm, if I'm right. And it also supports record processing and serialization across all of these different applications. So when you talk about wire formats, and since Cask is internal, we just have it there just for the sake of record. But if you talk about wire formats for this, when including the schema as part of your data packets, you need to give a schema header, and the schema header could be X number of bytes. So if you look at the Confluent schema has a 5-byte header, and the schema ID itself is about 4 bytes. It's an integer, and you have an extra byte for the magic byte or the protocol version, the version of the schema that you're using. And the Hortonworks is more involved in that you have the same magic byte, which is a single byte. The schema ID is a long, and hence it's 8 bytes long. And the schema version is an integer, which is 4 bytes. It's an integer of 4 bytes, so it's a 13-byte header. And we'll be looking at examples of the 2 different schemas in the upcoming slides. So here, this is a matrix, kind of like a feature comparison of the different schema registries that you have today, Cask, Confluent, and Hortonworks. So the REST APIs, yes, all of them do support REST APIs. The schema formats, Cask has Avro and protobuf, whereas Confluent and Hortonworks have only Avro. And the advantage of Hortonworks schema registries, it supports custom serialization and deserialization. Do you want to explain that?
Yeah, so, if we look at it today, so Avro support's really where things are at, and it's mostly because, if you start thinking about the concept as this came along, a lot of it was to, sort of serve this Kafka integration use case, so that you weren't stuffing your schemas on top of every single message. That's clearly inefficient. So that's sort of the first thing that people tackle, but in principle, there's nothing to say this could be any format whatsoever. These could be C structs. These could be anything that people are serializing and sending over the wire. So while today there's support for Avro, there's a facility there to store and push around your own custom serializer and deserializer, which could be anything. So the other things that I think are worth drawing out here are differences in between what the storage mechanisms look like, and then what high availability looks like if you're deploying these things. So with Confluent, they're actually storing the schemas in a topic, so you get replication there for free. So which is nice. But then on the HA side, it's a pretty traditional master-slave architecture for the actual schema registry API itself. On the flip side, with Hortonworks, most of the storage in terms of redundancy there is going to boil down to, are you backing it with some sort of database that is replicated or redundant? The HDFS bit is for storing serializer, deserializer jars, and things like that. So that, of course, is going to be redundant there for you. But then otherwise, on the HA side, for the actual registry API, that's a pretty simple matter of just having a load balancer and proxy, because we're assuming that this storage was, that storage had some kind of replication to it. So.
Okay, so moving on. Any questions so far on this? Okay. Oh, great.
Do you want to rate our application?
No, thanks, later. Okay, so how do you use a schema registry? It's froze. Okay, sorry. So here's an example screenshot of how you add a schema, a custom-defined schema. So this is using Hortonworks schema registry portal. And so I define, let's say I'm trying to add a schema for a Twitter feed. So I define that I give it a name and description. And the type is Avro, since I want to store in Avro format. And the compatibility forward is for the Avro formats. It's forward compatible. So I define my schema text. I copy paste my schema text there, and I click save. And then it creates a schema entry. And it's giving me a version number, version 1. And you can also see a log, change log, as to what's happening. It's created. Now, I want to go back and edit the schema. I can just go back and edit the schema and change some fields. And when I persist that, I get a different schema version number, and you can also see the change log, what's happening. So you have provenance, data provenance as to what's going on, and you have version compatibility. And since the REST APIs are versioned, you can go back to the older version, I can go back to version 1, or I can go to version 2. So with that, I'll hand it over to Joey to walk us through how to use a schema registry in a data pipeline using Flink.
Yeah, so what we want to illustrate here is, what is really the payoff with this? So if all you were doing was sending some data into Flink or a single system, there's not as much of a payoff. So there's that operational efficiency that you'd get, let's say, from not serializing embedded schemas along with every single message. But there's a lot more that you can get out of this. So we've already talked about how there's sort of the scaling friction that you end up with. If you're trying to play that game where you're going to have the embedded schemas, or you're going to have your code project specify what your schemas are, and then just leave it up to the application developer to know which topic has which schemas. So that doesn't scale across multiple different systems. So what we want to show an example of is, so if you're doing some kind of data acquisition, the first mile ingest from something like NiFi, sending messages over Kafka, and then doing some more complex processing over in Flink, what does a schema registry give you there? So what it's going to give you is that you're going to be able to be using the same schemas in that decentralized way on both sides of the fence here. And so that's really important, because then, let's say, on the NiFi side, you don't have to be thinking, you don't have to think about, okay, I specified the schema here, or I built a processor that, had that compiled in. And similarly, on the Flink side as well, both of them are going to talk to the schema registry to figure this stuff out. So the general flow is going to be something like, the source data is going to request a schema on the basis of an ID or a named schema. So you're going to hit the schema registry for that. You're going to receive back some kind of associated schema. And then once you have that, you can serialize it according to what that schema is, and then that wire format that is appropriate for whichever schema registry you're using. So you're going to get a small header and then the contents of the thing. And by talking to the schema registry, that's going to tell you how you're going to do that. And then on the other side of things, you can consume from Kafka, but that message now has this reference in it, right? And since it has a reference in it, you can just go look up that schema in the schema registry. You don't have to specify, in your code, this is what the schema was, or this is what the class was. So those options are still there, but there are drawbacks. And then, finally, you can, deserialize and then do whatever stuff you want to do. So we're gonna click through and sort of show what this example looks like, throughout. So, first off, so I said the first mile, of the data acquisition is happening through NiFi. So in an example data flow, let's say we're pulling in data from a Twitter stream. I've described two scenarios here. The one scenario involved using embedded schemas. The other scenario is what we're really advocating, which is like when you're doing this kind of processing, start thinking in terms of a schema registry so that you can decouple these things. So it's a pretty straightforward flow. If you haven't seen all of this before, so those boxes there and there's actually more underlying those, whereas these are sort of more monolithic units. So that Twitter sample stream actually talks to the Twitter API and does a little bit of filtering and some other stuff, let's say to get rid of deletes. So in here, we then have something, publishing Kafka records, but it's using the embedded schema. So what we're doing here is we're converting that record and then just publishing it to Kafka the usual old way. On this other branch here, What differs is that this version of this published Kafka is going to be using a schema registry to do it, and so it's not going to have that embedded schema. So, and then there's some other stuff out there so that you can actually just sort of get a sense of what the data is coming across. Okay, so part of what we're getting at is that there are different schema access strategies. So this is both going to be true at the level of your application, but also just more, more conceptually when you're thinking about this stuff. So there's the embedded schema. That's the thing we're saying, there's some problems with it. There's using some kind of metadata reference. That's what the schema registries are going to be doing. And then finally, the implicit schemas, which is what you see a lot of people. If they're not embedding the schema, that's what we've done today. And so your application ends up doing one of two things. You know that that topic has these specific objects coming across, or you just iterate through all the things you know might be possible, and then eventually you get one that works. So, we're going to look at sort of what some of the output of these serialized objects looks like, and then show some examples on the NiFi side of thing, how it's configured, and then look at the actual Flink deserialization schemas. So first off, with an embedded schema, so this isn't even the entire message. So if we look at something serialized with the embedded schema, it's all schema. No message. So if we move to the next thing, so we've actually now fit the entire message on this screen. So that was probably only even a fourth of what the schema actually was when it was serialized there. And so what I have outlined in red there is that's going to be that 13-byte header. And then after that, you get the message. And then similarly on the Confluent side, so as we said, we're only talking 5 bytes there, so there's a little bit less. So now if we, so I already alluded to this. So if we're going to be publishing, to Kafka with an embedded schema, there's a processor in NiFi called convert record. And it's going to let you choose one of these schema access strategies, more or less, and then you can just publish raw. That counterpart is the more, the record-aware variant of this, which is this publish Kafka record. But so this helps us understand what some of the configurations look like.
I'll flip it.
So first off, every record-aware processor in NiFi has a reader and a writer. That reader and a writer is going to specify something that's called a controller service, and that controller service is what implements how that reader and writer works. So that can be shared across different processors. So you can think of a processor as a particular step in a data flow, and the controller services then is a reusable component that those can use to do the reading and writing. So in this example, I have a reader and writer that are just using schema text, and we'll see what that is. It's literally just going to be dropping the schema into this text box. This isn't what this is a piece of functionality, but it's not the thing that we're ultimately aiming for. But as part of that, what we end up with is an embedded schema. Now, on the flip side, if we use the schema registry, instead of using that embedded schema and literally putting the schema text into the configuration, we tell it that it's going to be content encoded, and that's just going to mean it's going to be in the header. And we're going to use the schema name to actually do the schema lookup. So that's something that in this data flow is mostly hard-coded, but that could be at the same time on the basis of the actual content of the thing, the source of the data, file names, whatever you want. The goal is really you just need to be able to get an attribute onto your data that is a schema name. And like I said, so these controller services get reused across different types of processors and different operations. So the same writer that can be used on the convert record can also be reused for the publish Kafka record. So, okay. So then on the Flink side, I mean, this is fairly modest at the end of the day. Like, part of the point is that this is something that I think we need to start thinking about and that the community needs to think about is like, how should these problems get solved when you're trying to integrate, across system and application boundaries? So, the first step's going to be you won't need to get the schema metadata out, and then you want to split that metadata and the contents, and then get that schema from the schema registry, and then deserialize. So this is where you handle the wire format. So it's really just going to be a matter of checking that the message is big enough, period, and then pulling off the bytes that you need to get that particular format. Then this is straightforward, just dropping the header off separate from the actual contents. And then you're going to see a bit of difference between the two options here if you're using the Hortonworks registry versus the Confluent one, which is actually getting the schema from the registry. So in both cases, you have a registry client that you use to actually pull this data in. That's going to be there in the modules in the particular project. But on the Hortonworks side, remember, we have a schema ID and then a schema version that's both in the header. So there's more steps there to actually put that together and then pull the schema down. So you're going to have to get a metadata object, you're going to have to put a key together, and then finally you're going to do the request for that schema and then return it. Deserialization then is pretty straightforward. There's not really anything interesting super interesting going on here at that point. You're using the binary decoder API because you're going to be providing it a reader and a decoder. Now, one little gotcha here is that you aren't going to know your schema until you actually look at that particular message. In principle, you could have a topic with messages, like heterogeneous messages. So what you can't easily do, with this sort of approach is reuse the reader. So, that's fine, but so almost all this is, parallel, as we already discussed, but like I mentioned, getting the schema is sort of, much simpler here because it's really just take that ID, do the lookup, return the thing. So, okay, so I think, how are we doing on time? So we have a little bit. So we can actually dig into this some and actually see it running. So I don't think that's quite big enough, so let me zoom in here.
Minimize the side ones.
Yeah, I can. Okay, so the sample stream, like I said, we're doing a little bit more here than just like fetching something off the stream. We're filtering out we're filtering out deletes and other updates that are junk. And I'm also trying to control the rate a little bit so that I can actually run this demo locally and not have to worry as much about my machine blowing up when I'm running it. So I'll go through step by step now. So I can start up the sample stream. So first thing we're going to start seeing is messages coming across. Now if we dig in and look at these messages, they're going to be as we expected. So there's just some JSON payloads. Does that make sense? Okay, next step. So each one of the branches is going to work slightly differently. So I'm going to double click into this one first. And this is the variant where we're actually using the embedded schema. So if I start these components up, what we're going to see next is a bunch of stuff's going to get queued there. And so these have been converted now to Avro. So let's look at what that actually looks like. Okay. So if I go and look at one of these, we'll see the same thing. We have a whole bunch of the schema stuff embedded. And we can format this and see it nice and pretty, but really that entire schema is embedded there. Okay, the next bit. Now, this variant of the publish Kafka is just going to publish those raw bytes, so that schema will still be there. That is not record aware, so the convert records aware of schemas. This one is not aware of schemas. So if I bounce over here, and apologies for the playing in the terminal, what we see is, okay, so we have a whole bunch of these messages, and these are the ones that I illustrated where we have huge Avro schema at the head of it. Okay, so if we bounce back out and look at the other branch. So the first thing we're going to do is we're going to specify what the schema name is. So here, I just set that. That can be, that can be found via runtime. So that's just, an artifact of it being an example. And then we're going to publish that record with the schema coming from the schema registry. So let's start these up. And we'll start to see, okay, the stuff churn along. Okay, so there's a little example Flink job here, and you're going to tell it really the schema type. So this is really whether you're using a registry, whether it's embedded, and so on. The topic that you're going to be operating on, and then just some output. This is just mostly based on the Kafka examples that are there. Okay. So everything starts going, and this particular job is then just pulling out a subset of the fields and dumping them as TSV. So if everything's going as planned, we should see this. I did something slightly dumb here, so we will not see that because that file already existed. So let's give it a second go. And okay, there we go. So end to end, what's going on is we're pulling in some, data. We're using the schema registry to serialize. We're sending it across Kafka. We're using the schema registry on the Flink side to deserialize. And then we're just, dumping out a subset of the fields because we now know what the schema is on both sides. So it's a fairly simple, concept, but it ends up being really important for some of the reasons we mentioned. So you can't really scale your systems like in a practical sense. I'm not talking about throughput. I'm talking about how you wire stuff up together and connect things. If you're going to have to just, if you're going to be compiling stuff into your project or, just doing things implicitly, knowing that, one source is serialized in a certain way. And then on the flip side, if you embed the schemas, there's big storage and performance implications for that. So, not rocket science, but at the same time, an important thing to keep in mind. So, just sort of to tie things up. Really, what we want here is probably to push this to the layer of a table source and a table sink. That would make things, appropriately high level. That's really what you want to be thinking in terms of that level of abstraction, where it's like I have a source with an associated schema, not I have a deserialization schema and a consumer, and I'm going to tell it what to use. So any questions or thoughts? So yes.
Thank you for your talk. Really interesting to see something like which you don't hear that much in research, for example. But I'm still not understanding every part of it. I'm thinking from a developer point of view. So you have some kind of data source where you don't know, how you implement, how to read it, basically. Mm-hmm. So in this case, what you just have is you have the way it's represented in the record itself, right? And then you have this automatical operator which interprets the data.
Yeah.
But when I write a program and I have this easy source, I don't know if I have the Twitter thing and I want to do some analysis on that, I still need to know how that record looks like. So I would still need to go maybe to this database and look it up. Okay, is a tuple 2 of 2 whatever strings or something.
No, that's definitely fair. So there's always going to be some kind of entry point.
Okay.
The difference with this kind of approach is that it's going to put you in a position for things to be more configurable. So if you have a source, whether it's a location on a file system or a business partner that's sending you this data, if you have a way to identify sort of that entry point is this type of thing, then the rest of it can just be driven off of, okay, I know there's an ID that I can do this look up to hit the registry at. I mean, there's always going to be some place where you have to know something, but that can also be, in this case, part of the data itself. So, if you were doing it in terms of specifying the class and your type parameter that you're going to be using, okay, so you could configure that and make that as part of the job parameters. But what that can't do is you can't look at the data and then make that determination in the same way. Okay. I think that this sort of approach ends up being more flexible because you can look at that data and you have an identifier, you can do the lookup, get your schema, and it can be used on multiple sides of a fence.
Okay.
So,
how is the overhead? You still have a couple of
yeah, there's some overhead. So if you were to look at both Confluent and Hortonworks implementations for the actual Java client, they both are caching there, in memory with some kind of TTL. So the obvious thing that you would do. So it'd be fine. There's just normal stuff. So,
thank you.
Hi, thanks very much for the talk. I can see that the schema registry is really useful when you're wanting to share access to the data across teams.
Mm-hmm.
Have you got any sort of general guidance that you can offer around the governance of schemas?
So let me bounce back to something here if we were to look at. Okay, so let's just look at this for a second. So all of the choices are going to version things, but that's not quite governance. So there's a missing column here in terms of schema composition. So I'm actually not 100% sure if Confluent can handle this or not. But so on the Hortonworks side, you can actually, the same way in Avro that you would reference out to, another schema and, in a parent schema, you can do the same kind of thing, but also within the registry itself. So that starts to push you in this direction of having, more robust, governance capabilities. Because you can imagine a point at which then the schemas being composed aren't necessarily all owned by the same teams. So now this isn't something that's there today. So, this pretty much across the board, these are all works in progress. And I know there's some sort of plan or thinking around where does Atlas come into play with some of this? So, because once you start thinking about these registries for things, it's not just about a schema registry. There's, metadata management. The questions around model registries are becoming more and more common. And so, where I come from, the sort of standard way of starting to think about that is what does Apache Atlas bring to the table there? And so, but this is all very early, and so if you look at the open source project that's there, this is what's there. So.
Hi, thanks a lot for the talk. Have you heard of some schema registry that can handle multiple types of schemas concurrently, like Avro or EMF or JSON schema or something like that?
So do you mean do you mean in the sense that it supports two kinds of schemas? So Cask actually has their implementation there in both Avro and Protobuf. So then there's I think both Confluent and Hortonworks have written things in a way that it can support that, but we're not as far along as we should be, community-wise, and having something that can cover cover the breadth of things. I think that that's actually a really important thing to keep in mind here, is that if part of the promissory note is that this makes it more palatable to be dealing with systems that are distributed in some kind of fashion, then what we really need to be thinking about is covering all of those scenarios. So, for example, in the work with the Apache Streams project, so everything there is done using JSON schema. Kind of come up empty-handed today when thinking about, well, can we leverage some of the tools that are there for all the schemas that are over in this other project? So.
Yeah,
So the answer is sort of no, but I think everybody has their eyes set on that and has been trying to implement things in a way that doesn't box us out of the different options.
I was just wondering, so how much of this schema information and the schema ID is just information, and how much of it is actually validation against a particular schema? Does it just go with it, or is there actual places where there's something like similar to XML schema validation, where you actually verify that a message conforms to whatever schema it says it would conform to?
So Avro's not going to let you deserialize if
Yep.
it's bad data. So that's the easy one.
Yep.
So there's sort of another angle to that question, which is, do the schema registries tell you when you are doing bad things when you're storing your schemas? So so there's the whole forward and backward compatibility issue, but there's also the, if this is integrated into some kind of application and somebody goes and tries to write a schema to it, is there a way to validate that that's going to be a compatible schema before you just try to persist it and it fails? So, but.
Where do you think schema registry help with schema evolution?
Sorry.
The schema evolution, so where does it actually...
So, well, there is no uniform standard, and somebody needs to evangelize this and standardize across the different layers around there. So, not sure what the answer is. Yeah.
I mean, I think the only thing that this gives you today is tracking the things that you're actually evolving. Mm-hmm. So while there's nothing specific about, it's not telling you anything super insightful about how it evolved, you have a changelog of the things that did. And so, and that's more, that's accessible, outside of an individual code project. So.
Any other question? Okay, let's thank our speaker.
Thank you.